right, hello. We are going to apply the parallelogram properties and use algebra and intertwine geometry with algebra today. So first of all, let's just do a warm-up. So I want you to try both of these questions. You do for the diagonals part. So first of all, these are parallelograms given to you, but also diagonals. You will have to draw in diagonals. So that's one diagonal. And then here's another diagonal. So mark this picture with what you know about the sides and diagonals, and mark this picture with what you know about just the angles. Okay, so what you're going to do for sides is you know that opposite sides are congruent. So these sides are congruent, and then these other pair of opposite sides are congruent. Now, what you know about diagonals is those bisect each other. So bisect, remember, cuts into congruent parts. So that means that this little segment and that little segment are congruent. So I'm going to mark those with 3 ticks. Those go together. And then these two also go together. So those two are congruent. So these are the 4 different pairs of congruent segments. For the angles, what you know about the angles of a parallelogram is opposite angles are congruent. So you put curves that match opposite ends, and then you can do a double curve here, and then those are congruent. So opposite angles are also congruent. Okay, so we are going to go through 3 of these examples together. This should be fairly straightforward using the properties we just went through again. So here, again, you have to know that it's a parallelogram in order to set anything up with those properties. So here I have 2x plus 15 is ST and x plus 15 is RU. Well, we know that opposite sides are congruent. So that means I can simply set up 2x plus 15 is equal to x plus 15. That's 15. And then there's your equation, and then you go and you solve. So this one should be fairly straightforward. You're going to subtract x from both sides. So I have x plus 15 equals 15, and then subtract 15. So I get x equals 0. Always, always, always put that into your picture. So x times 0 is 0, so that means this is going to be 15. And then obviously 0 plus 15 is also 15. But if you check in the picture, you can make sure that you're correct. Okay, next one. So we're going to do number 5 and number 6. Number 5 is actually the hardest type for most people. So first of all, the 9x plus 15 goes with this angle here. And then the 6x plus 15 goes with the other angle here. And I'm going to mark those differently because they're not opposite angles. Opposite angles are congruent. These are consecutive angles, or what we talked about in the previous chapter, or a couple chapters ago, that these are called same side interior angles. So remember, same side interior angles are supplementary. And if you remember, supplementary means they add up to 180 degrees. Okay, so that, for some reason, kids have a hard time with that. So if the angles are not opposite, but consecutive is what it's called, those are going to add up to 180. So setting that up, you do 9x plus 15 plus 6x plus 15 is equal to 180. Okay, why don't you pause and solve that and label the picture. Okay, welcome back. So you're going to combine like terms. 15x plus 30 equals 180. Okay, subtract 30 from both sides, and you get 150. divide by the 15, and you get 10. Okay, we are going to take that 10 and plug it into the picture to confirm we are correct. So 9 times 10 is 90, plus that is 105. And then here's 60, plus the 15 is 75. And then 105 plus 75 is 180. So that, again, checks out. Okay, next one. So here we have the diagonals in the picture. U is indicating this midpoint here, and we're going to label the picture. So KU is 3x plus 3. So this right here is 3x plus 3. And then UM is 4x minus 4. Okay, and from the top picture we just did, so remember from here, you know that these two little segments are congruent and these two little segments are congruent. So what we can do is just set those equal to each other. So 3x plus 3 is equal to 4x minus 4. And then why don't you pause, solve, and plug in. Okay, welcome back. So you should subtract 3x from both sides. And you get x minus 4 equals 3, and then add 4. So x equals 7. All right, now we're going to plug in to make sure that works in the picture. So here I get 3 times 7 is 21, plus the 3 is 24. And then 4 times 7 is 28, minus the 4 is also 24. So again, that checks out. Okay, if you go to the back, which we will work on in class, these are more challenging algebra questions. So here you're going to find x squared questions where you have to factor, and system questions where you have to solve with substitution or elimination. But we will do those ones in class. Okay, great. See you next time.